Hey folks, in this short video, we're going to prove the law of sines. We're going to learn where the law of sines come from. And the law of sines is this cool little tool that states for any triangle ABC with side lengths A, B, and C, that this relationship holds true. And it isn't limited to right triangles. It works for any triangle. And it's the fact that this side length divided by the sine of the angle opposite it. Note, this divided by the sine of this angle equals this divided by the sine of this angle equals this divided by the sine of this angle. So if this relationship is true, we know that its reciprocal is also true. So while you'll see both forms of the law of sines, I'm going to prove and work with this form on the right over here in my example. And so to do this short little proof, I'm going to begin with just a triangle with angles A, B, and C, and then the corresponding sides opposite those. And I'm going to construct an altitude from A. And I just picked A randomly. You could start from any side. And if I got my altitude there, we've now kind of created two little right triangles within our triangle. And I know that from this angle, the sine of this angle is equal to opposite over hypotenuse. So in our little right triangle on the right side of this, sine of C equals H over B. And then the same thing, I could write an equivalent equation for over here on the left side. The sine of angle B equals H over C. So I've created two little sine equations, and I'm going to rearrange both of them. This first equation, I'm going to solve for H by multiplying by B on both sides. And that creates this equation. So when you multiply by B over here, it cancels, and then you have B sine C on the left side. And then I'm going to do the same thing to this equation. I'm going to solve it for H by multiplying by C on both sides. And so I've created these two little equations that are both solved for H. And if I have this equation equals H and this equation equals H, we know that those equations are equal to each other. So I can substitute them into each other. And from here, it's really just some algebraic rearranging. I'm going to keep my sine C here, and I'm going to divide by B on both sides of my equation, and boom, we're here. And then I've got this C coefficient right here, and I'm going to get rid of it. Since this is sine B times C, I'm going to undo that by dividing by C on both sides, and we end up here. And this is basically part of our law of cosines. You might at this point kind of be concluding that we could keep going with this to get the sine A over A part of it, but I'm going to go and show that here on the next slide. I've snipped what we've already proven here. And we're really just going to repeat this process with a different altitude. I'm going to now construct an altitude from point B. And so I'm going to call that Z this time, because I'm not going to call it H, because this is a different altitude than we used on the previous slide. So I'm just going to call this Z, just some random variable. And we're going to write our two sine equations. I know that the sine of angle C equals Z over A. And then I know the same thing from angle A. The sine of angle A equals opposite over hypotenuse, equals Z over C. And just like we did last time, I'm going to isolate Z by multiplying by A on both sides. Boop. And then I'm going to isolate Z by multiplying by C on both sides. And we end up with these two equations that are solved for Z. And since they're both equal to Z, we can set them equal to each other. Now that we're here, I'm going to keep sine of C here by dividing by A on both sides of my equation. And then I want to leave sine of A here, and I want to get rid of the C, and I'm going to divide by C on both sides of my equation to do that. And now look what we've got. On the previous slide, we said sine of C over C equals sine of B over B. But then right here, we said sine of C over C equals sine of A over A. So I think it's safe to conclude at this point that all three of those are equivalent. And it looks like my little thumbnail, my picture is in the way there. But we've just done it. We have proven the law of sines. Now in my next video, we're actually going to learn how to use the law of sines to solve for missing side lengths and angles in right triangles.